All right, boys and girls, here we go. We have day 3 of April Daily Math. So let's go ahead and get started. Number 1, April showers bring May flowers, or bring lots of flowers. So if April showers bring May flowers, what do May flowers bring? Answer later. Number 1 here, 27 daffodils and 32 pansies, plus some tulips, which we don't know, but we do know the total is 73 flowers. So in order to figure this out, I think we really should probably figure out how many daffodils and pansies we have. So let's go ahead and let's add together our 27 and our 32, okay? And 7 plus 2 is 9, 2 plus 3 is 5. So we have 59 flowers plus some tulips. And that gives us a total of 73 flowers altogether, okay? So we can either go 59, count up 10, okay? So if we add 10, we're going to have 69, and then we can count up to 73. So 70, 71, 72, 73. Okay, so there's 10, and then 11, 12, 13, and 14. So our answer is 14 tulips. Okay? We could do it this way as well. We could take our 73 and take away, because we know part of our answer is 59, the other, and our whole is 73. So you have a part, an unknown, and a whole. So 73, if we take away our 59, more on the floor, borrow next door. 13 minus 9 is 4. 6 minus 5 is 1. So again, 14 tulips. Okay, either way, same answer. All right, number 2. We have write less than, greater than, or equal to, and what we're trying to do is I'm going to write this a little bit bigger, like that, okay? 3/4 versus 3/8. We want to compare those two, all right? So I think the easiest way to compare them is let's make them the same number on the bottom, the same number as a denominator. So we can take this 4, okay, and we can, if we times 2, multiply it by 2, it gives us 8. So we're going to rewrite this and say an 8. We're going to keep this at 3/8. And if we take our denominator times 2 and get 8, we're also going to take our numerator times 2, and that's 6. So 6/8 is greater than 3/8, okay? So therefore 3/4 or 3/4 is greater than 3/8. Again, if you remember our trick from the Math in Focus, same numerator, then we look at the denominator, okay? The 4 and the 8, meaning that the smaller number is the larger fraction. We must have someone walking by. Our dogs going crazy. Number 3. So here we have a little multiplication table. And we have our times, and on this 4, 5, and 6. Across the way we have 5, 6, 7, and 8. And I'm just going to draw some lines in there, like yay. And it looks like we have a 5 and a 6, and that's a 30 that they give us, okay? So let's go 4 times 5, and there's our 20. 4 times 6, 24. 4 times 7, 28, and 4 times 8 is 32. If you notice each one of those, we add 4, okay? 5 times 5 is 25. 5 times 6 we already have is 30. 5 times 7 is 35, so we're counting by 5. So 25, 30, 35, 40. Sometimes just thinking of it differently almost makes it easier, you know? When we're counting by 5, sometimes, you know, 5 times 5 or 5 times 7, 5 times 8, oh, what is it? But if we know when we can count by 5s, it makes it just a little bit easier for us. Let's go 6 times 5. Well, we did 5 times 6. This is going to be the same as 6 times 5. That's also 30. 6 times 6 is 36. So we added 6 to that. So 6 more to 36 is 42. which is also 6 times 7. And 6 more would be 48. 6 times 8 equals 48. All right, number 4. We have 389 plus something equals 856. That's a part-whole question. We know one part, we know the whole. So what we're going to do is take the whole and we're going to subtract the part. Okay, if we take the whole, we subtract the part, we get the other part. 6 minus 9, there's more on the floor, got to borrow from next door. 16 minus 9 is 7. 4 minus 8, again, more on the floor, borrow from next door. 14 minus 8, there's 4 above 10, 2 below, so 4 plus 2 is 6. And more on the top, no need to stop. 7 minus 3 is 4. So 467 is our other part. Okay? Let's go to number 5 now. This would be a great one. I almost don't want to answer it because I really want to hear what you have to say. Write 2 things you know about a rhombus. Okay? So what I did is, I got a couple of them, all right? A couple examples of a rhombus. Okay, so on a rhombus, we know that all 4 sides are the same length. Okay? So if we look at the side of the narrow rhombus, the tan one, this, and this, all 4 of those sides are the exact same length. We know all 4 sides of this are the exact same length. So there's kind of a progression with the rhombus. If you start with a really, really narrow one and you squish it, see I'm squeezing it. I'm squeezing it down just a little bit. Same rhombus, just a little bit wider. Okay? Check that out. Yeah, same length. Now, if I squeeze it down just a little bit more, I squeezed that one a lot, didn't I? This could also be thought of as a rhombus, right? Are all 4 sides the same length? Okay. Are these 2 angles the same? And are these 2 angles the same? Are these 2 angles the same? And the opposite angles the same. So we have all 4 sides are the same length and opposite angles are the same length. Okay? So you kind of see, look at that, it's the same. Oh my goodness. Check it out, check it out. Ready? Oh yeah. All right, there we go. So that is a great answer for number 5. If you have questions, let me know. If you want to share it with me, hey, email it to me, okay? Or throw it on Google Classroom or something. Let me know what you got. All right, boys, girls, talk to you later.